This is the third part of the videos on deriving formal trig identities. In the other videos, we came up with some nice sum and difference formulas for sine, cosine, and tangent. I'm just going to quickly recap those sum formulas here. For sine, it would be sine alpha, cosine beta, plus cosine alpha, sine beta. And for cosine, it'd be cosine alpha, cosine beta minus sine alpha, sine beta. And then lastly, for tangent, it's clearly sine over cosine, but you can also write it as tan alpha plus tan beta over 1 minus tan alpha times tan beta. Okay, so what we're going to do is we're going to take these now and we're going to go and we're going to derive what are known as the double angle identities. The double angle identities are probably the most useful of all of the different trig identities that we've seen so far. So we'll start with sine's double angle. Sine's double angle identity comes up with another way to rewrite sine of 2 theta. Well, I say another way, but really I guess it's probably our only way to rewrite it because, of course, it is not equal to 2 times sine of theta. This is a change in frequency, and if you bring the 2 on the outside, that's a change in amplitude. So what we want to know is, can we just rewrite it in terms of just a single theta rather than a double theta? So what I could do is I could think about 2 theta as being, well, theta plus theta, one plus another. And in that sense, I can go back and I can use the identity that I established about sine of alpha plus beta, where alpha and beta were thought of as 2 different angles. Now I'm just thinking about them as the same angle. So following that prescription, it'd be sine of the first angle times cosine of the second plus cosine of the first times sine of the second. And since the first and the second are really the same, and because multiplication here is commutative, this is just 2 sine cosine. And that's a new way to rewrite sine of 2 theta. So sine of 2 theta is equal to 2 sine cosine. That's my double angle identity for sine. I can do the exact same thing here for cosine. One thing that you'll see is cosine has a few different versions of its double angle identity. So I start with cosine of 2 theta, and I rewrite it as cosine of theta plus theta, and I follow this time cosine's prescription right here, cosine alpha plus beta, and when I do that, I get cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second, which of course is equal to cosine squared minus sine squared, not to be confused with cosine squared plus sine squared, which is always equal to 1. And that is cosine's double angle identity. Cosine of 2 theta is cosine squared minus sine squared. I say there's a couple different versions of that because we know that sine squared and cosine squared are related through the Pythagorean identities. So you could substitute out the sine squared with a 1 minus cosine squared, and you get 2 cosine squared minus 1 after you simplify. Or if you wanted to do it the other way, you could substitute out the cosine squared for a 1 minus sine squared, and you get 1 minus 2 sine squared. And those are the 3 different versions for cosine's double angle identity. Lastly, we can think about tan's double. Tan's double angle identity is also easy to think about through its angle sum. So this is tan of theta plus theta. And now I'm just going back and I'm thinking about my angle sum identity for tangent right here, where it's tan alpha plus tan beta over 1 minus tan alpha times tan beta. So here, that would give me the fraction tan theta plus tan theta over 1 minus tan theta times tan theta, which of course is 2 tan theta over 1 minus tan squared theta. And that is tan's double angle identity. Okay, so that concludes a quick little video here on all the different double angle identities. One thing to keep in mind is there are 3 variants there for cosine. In the next part of the video, we'll start to see how all this stuff becomes extremely useful when we're working with equations, inverses, or maybe other identities.